So solving rational equations is definitely something you have to put in a different spot in your brain. You have to have a different process for it than simplifying expressions. Here, we are going to get rid of our denominators. You can absolutely find a common denominator if you would like, and then cross multiply, that works. But the way that I presented this in class, and I think the most efficient way to go about this, is to cancel the denominators. The first thing you want to do in order to cancel denominators is factor anything that is factorable. For this problem, x plus 2, already a binomial. X minus 5, already a binomial. This guy is not. This is x, let's see, two numbers that multiply to negative 10 and add to negative 3. X minus 5 and x plus 2. So what we want to multiply by is the least common denominator, and the least common denominator is what we can multiply every term by and get rid of every denominator. So I want to multiply by x plus 2 to get rid of x plus 2. I want to multiply by x minus 5 to get rid of x minus 5. And both of those are there, and so x plus 2 times x minus 5 will get rid of that trinomial. We want to cancel the denominators altogether. This process is different than finding a common denominator. Here we're canceling denominators. And the reason that we can do this is because we have an equal sign in our problem. On the last problem, on number 13, we could only multiply by 1 because we were simplifying. We weren't solving. We couldn't do something to both sides of the equation. We only had one side of the equation. Here, when we're solving for x, we have two sides of the equation. So as long as what we do to one term, we do to every term, we can multiply by whatever we want. In this problem, again, we're going to choose to multiply by x minus 5 times x plus 2. Now, in class, I showed this a bunch of different ways. Sometimes I showed it as multiplying it through with a little distributive property. If you're watching the video, it's probably because you need a little extra help, and if you need a little extra help, I think this is the thing to do. Write it with every fraction, and then cross off the things that are going to make 1. So for this first fraction, I'm just going to move left to right. The x plus 2 over x plus 2 would make 1. That's what cancels this fraction. So the x plus 2's are gone. What's left, I'm going to put in green here, x times x minus 5. Here, my x minus 5's cancel. So what's left, 7 times x plus 2. On the other side of my equal sign, my x minus 5 cancels, and so does my x plus 2. So that cancels that whole thing. What's left is just the 14. So by multiplying every term by the least common denominator, we get something that looks like this. Oh, I don't want to write in yellow, sorry. The leftovers from my first fraction were x times x plus 5. My second fraction is 7 times x plus 2. And on the other side of my equal sign, it was 14. And now we just algebra and solve equations. Algebra your way out of it. This one looks like it's going to be a trinomial, but look what happens when you're going to set it equal to 0. It's awfully nice. My x squared stays. Negative 5x plus 7x is positive 2x. I can take out an x. So that means that x equals 0 and x equals negative 2. Okay, 2 thing we need to check is whether these solutions work. So if I put either of these into the denominators, the original denominators, am I going to get 0? Well, if we go back and look at 0, I would have 0 minus, or 0 plus 2, that one's okay. 0 minus 5, that one's okay. And if those are okay, then multiplying them together would work. If I put negative 2 in, negative 2 plus 2 is going to be 0. So that is an extraneous solution. And that happens because we're solving a quadratic. Sometimes that'll happen and sometimes it won't. I think it's helpful, and what we did in class when we remembered was to say, hey, from the beginning, what can x not equal? Well, here, from this one, x cannot equal negative 2, and from this one, x cannot equal 5, because that would make zeros in our denominator. And so writing that off to the side in the beginning helps to kind of keep that in your mind as well. So if you remember to do that, that's phenomenal. All right, that was number 14.